Hi, everyone. I'm Hui Jin, the Key Account Sales in Malaysia and the host for today's webinar. Thank you for joining us in our webinar on next generation in unifying the IoT age. Before we begin, there are some housekeeping rules. First, please put yourself on mute during the presentation. Second, if you have any question or difficulties, please let us know by sending a quick message in the chat box. We shall assist you as much as we can. Lastly, you may put yourself on unmute during a Q&A session if you have any question. Without further ado, let's get started. The COVID-19 coronavirus pandemic removed work and strive to improve productivity while automation are speeding up the adoption of edge computing in the APAC region. Currently, North America, China, Japan account for the largest share of the edge computing market, and APAC is expected to be the next major growth engine. Across industry, the manufacturing, financial services, energy, IT sectors will be the keenest adopter of edge computing and accounts for half of overall spending in future. Key drivers for increased adoption includes AI, IoT, 5G. Even many public cloud providers such as AWS, Azure are also rapidly releasing new offerings for edge computing segment. Cloud computing is a centralized model, but when you start moving intelligence to the edge, focus will be on how to grow amid the challenges in this segment. Today, it is my honor to introduce four speakers, Mr. Edwin Teo, Ms. Alice Liu, Mr. Gordon, and Mr. Andrew, who will be sharing on the IoT edge trend, the solution, and the challenges. And what is the software that is required to achieve the optimal objectives? First of all, let me call upon Mr. Edwin Teo, the ASEAN Regional Sales Manager based in Singapore, to share on the focus on why edge computing, edge IoT gateway. Over to you, Mr. Edwin Teo.
Okay. Hi, everyone. Okay, my name is Edwin from Advantech Singapore. Okay. In many projects nowadays, we always have a compute device nearer the equipment that you need to monitor or to control. So we usually call this edge computers. And the past few years, edge computers has come into more renewed focus. Okay, so let's first look into the definition of edge computing. From Wikipedia, edge computing is a distributed computing paradigm which brings computation and data storage closer to the location where it is needed to improve response time and save bandwidth. Now, if you look from IoT 1, edge computing involves hardware and software technologies that enable storage, computing, processing, and networking closer to the device that generates or consumes data. Okay, in short, edge computing is whereby more and more compute workload, which are typically processed at the backend, at the cloud, are now processed at the edge, closer to where the data, the actual data is. The key drivers is mainly to reduce bandwidth costs and a faster response time instead of one round trip. That means you don't send the data, you don't send the data to the cloud for processing and then come back as a round trip. Instead, the data is now being processed closer to the edge. So if you look at a typical IoT architecture, okay, usually we always consider them three parts. The first part is the edge devices, the edge IoT gateway, the second layer, the middle layer, and then to the cloud, the backend, be it a public or private cloud. So if you look carefully, the key objective for edge devices are either to monitor or to control the end equipment. So we say monitor is more like the sensors, right? And then, hello, who is the, hello, can you mute yourself? Hello. So for the sensors, then if you want to control the device, it's basically the actuators. So such data are then sent to the edge IoT gateway for edge processing. The IoT gateway typically comes with the IoT gateway middleware, the software layer, which shall aggregate the filter, process the data, and then push the metadata to the cloud. Now, recently, as you know, we are getting more and more AI adoption. Larger IoT networks are found. And then future, there's going to be 5G. And all these are resulting in exponentially higher data traffic. Okay, just to base on each IoT gateway and send directly to the cloud, this concept needs rethinking. Okay, the demand for lower latency, basically when I say lower latency means you want faster response, and bandwidth cost consideration, it makes more practical sense to deploy smaller distributed data centers instead of consolidating all to a common cloud. That means now if you look from the diagram picture below, besides the edge IoT gateway, you start to see another thing into the equation, which is the edge cloud, or aka the edge data center. So the edge cloud concept is basically similar to centralized data center, but in a much smaller scale and are deployed closer to the edge. So each edge cloud may interface to several IoT gateway like a core network. So I have the edge cloud connecting to several IoT gateway as one set, one core. Then I may also have another distribution. Edge cloud connect to a few IoT gateways, and then all these will link together and send to the cloud. Okay, so such edge cloud also tends to utilize, because the basic concept is the same, they're tending to utilize the cloud solution architecture. So as you can see from a cloud, typically you see containers, load balancing. Okay, so all these feature function are also found on the edge cloud. Okay, and because the data are there are concerns on physical security, IoT layer security, all these need to take into account. So to summarize, we say edge computing solutions. We look at not just the edge devices, the edge gateway, the IoT module that's used to interface with the edge devices, be it by wired or wireless, then connect to the edge cloud, and after that back to the backend. Okay, so the future trend for edge compute shall basically be from the devices to the core and then to the cloud. Okay, now the five key benefits or the key drivers for edge computing. So I just list them one by one. First, reduce cost. In actual fact, this is the main driver. AI video analytics consume a lot of bandwidth, and to send such large bandwidth data to the backend or to the cloud for more in-depth processing, the bandwidth cost is typically quite high. So have the workload closer to the edge, you save such bandwidth costs. As you know from the public cloud vendor, they bill you by how much data that's been sent to the cloud for processing. So cloud basically means limited processing power. But when you send such large data sets, it's actually quite costly. Second, low latency. For certain application, you need fast response. For example, we talk about AI. In a fleet management context, when we say video analytics, when you do video analytics in a fleet management, you also need to think, is it going to be, there are certain AI application, you need fast response, immediate response. Certain AI application, you can wait. For example, if I were to do people counting, I want to do facial recognition, or to do object tracking, yes, these can wait a little bit. You don't need real time. But things that involve safety, such as blind spot detection or front forward collision, all these need immediate response. All these you need to process at the edge. Security, privacy. When you look at the cloud itself has actually many security function features. But outside the cloud, that's a different story. Okay, so how should you implement that? Okay, and many companies or many projects now look into edge, where you process everything at edge. That means you send less data through many nodes. That means you send less data through the network to the core and then straight to the cloud. All these actually are susceptible to intrusion. So you are reducing security concerns. Okay. Now, power efficiency. For certain edge gateways, such as those that's battery powered, drones, AR, VR, AMR, all these tend to be power constrained. So you need to balance the performance versus battery power. Lastly, scalability. This actually impact your edge computing device selection, because you got to think, am I future proofing my devices? Okay. Next slide. So, next slide. So when you look at edge computing evaluation criteria, that means how to select an edge computers. Okay, so there are various factors to consider. So I list them out on the slides. First one, on the left side, the IoT gateway middleware. Actually, this is the most crucial. Okay, because like it or not, when you select the IoT gateway middleware, you have to think, you have to do a lot of provisioning. You got to assess both the hardware and the software aspects. Okay, so if in the software domain, what is the software engine that's running on the unit? It means the actual IoT gateway middleware. Is it a proprietary version or is it a generic version? So what is the expected protocol that you need to convert and whether these protocols are supported? That means if, for example, I want to use CAN bus, which type of CAN bus? Are all these protocols able to convert? Which messaging protocols are you supporting? MQTT, CoAP, or others? Are the software tools open source? Are there any way to remotely manage the edge gateway or devices? What kind of security are protected? Root of trust, secure boot, and most importantly, is OTA supported. OTA means over the air, because you have to think of the practical aspect. Once you deploy the gateway, if you have a future updated version, you don't expect yourself or your guys to go down to the site and each one go update by itself. OTA is usually a key requirement. So when you select on the software side, please factor that in. Okay, on the hardware layer, you got to think of future proofing. Is the processor performance able to accommodate or provision for future upgrade and scaling? Okay, now look at what about wireless? Right now, on the horizon, we're going to see 5G, Wi-Fi 6. Is my current devices able to support 5G or Wi-Fi 6? Okay, so this is some factors you can consider because 5G nowadays comes in a slightly larger M23352 form factor. Wi-Fi 6 is always in M2. They don't come in mini PCIe. Okay, next, Edge AI. Hey, AI, especially comes to deep learning, has now been getting a lot of attention. Okay, so what is the objective for the IoT gateway? Are you doing machine learning, which is more CPU intensive, or are you doing deep learning, which is more training intensive? Okay, so deep learning. So deep learning is actually more for unstructured data. So when we say unstructured data, usually video, photos, all these, you may need AI acceleration chip at the edge. When we talk about at the edge. So first, you got to question yourself, am I doing for training or inferencing? Any power constraint issue? Okay, power performance is usually a tough balancing act because sometimes we do encounter certain customers who wants high power, but then they are not or high performance, but the power catered for is far too little. Environmental condition, where is the unit going to be deployed? Indoor, outdoor? Is there any IP protection? If it's outdoor, how wide will be the temperature range? Are there necessary certifications? Like, for example, I'm going to put on the train. Do I need to meet EN 50155 cert? Put in the hospital, critical care area. Do I need to meet EN 60601-1 cert? So all these kind of things need to take into account. And lastly, most importantly, is cost. When we look at cost, we look from the angle of TCO, total cost of ownership, which is basically the purchase cost, the downtime cost. That means what if the device is down? How much am I going to lose? How much money am I going to lose when it's down? That means when it's not working. Man-hour cost when you need to repair, or freight cost and all this kind of thing. Whether is it durable? Can it last 10 years? Can it last 5 years? Because when you deploy this kind of edge computing device, you don't expect it to change within 1 or 2 years. Okay, so do take into account TCO. I do see many customers looking at just purchase cost and forget about the rest. So if you tabulate the entire thing, it becomes more costly. Next slide. So if you look at market trends in terms of edge computing, okay, edge computing, what's coming up? First, decoupling. Okay, in the edge computing landscape with regards to IoT gateway, there are now actually many different offerings by different companies, each emphasizing on their core strength of their own IoT gateway software and helping the SI to collect data, aggregate, and push to the cloud. The term IoT means Internet of Things, means by right, each things can communicate with each other in the network. However, one market reality you want to take note is that most IoT gateway platforms are in a sense, proprietary. So what they do, how they convert protocols to which messaging protocol they use. Are they using the standard MQTT or a modified version? Okay. And if you notice different brands of IoT gateway, you can't share, you don't seem to be able to share the data. Whatever data you need to collect at the cloud, you need to share at the cloud. So there's a missing piece of the jigsaw, which gateway to gateway by different brands or different platform, you're not able to communicate, not able to share data freely. So in order to decouple, how you decouple? In fact, when you look at government, most government fear tie in by vendors. One approach of decoupling should be covered in today's webinar. You should use EdgeX. So EdgeX is basically a form of IoT open source IoT gateway middleware, where they have many services, the core services, import, export, security services, management services. The key is the core services. As long as that IoT gateway has a EdgeX plugin, follow the data structure, you can actually, between brands and different vendors, you can actually communicate and share the data accordingly. Another trend, AI chip. Okay, new AI inferencing, ASIC, especially ASIC chips, are actually more and more new AI chips are being released in the upcoming years. So when you look at AI edge analytics, usually the two companies that you come into mind, NVIDIA, Intel, right? In fact, this AI world, you see more and more AI chip, especially lower power ASIC. So which are those? And then another trend that you will notice is that many of the processors are also incorporating AI distribution into their main core chip. That means into their main processor. I'll give a few examples. Intel, the new Tiger Lake UP3, which is the ultra low voltage Core i series, the 11th gen, incorporate vector neural network instruction sets, VNNI, which was previously in their scalable Xeon. Rockchip RK3568 also include an internal NPU now. Even NXP IMX8M Plus also have their own NPU. So each with different power rating and tops. Okay, Neuron is also another player in the market with an ultra low power 0.5 watt AI accelerator chip. So you can see more and more are being released in the market. 5G, this one is the next wave. Okay, you can connect to far more nodes and also faster speed. So 5G basically, you divide them to public 5G and private 5G. Public 5G, I would say it will take a bit of time to grow. It's not like 4G, because 4G, base station to base station, you can have it in a few kilometers, whereas 5G, you have it in less than 1 kilometer. That means the distance between base station, which means the telco need to put in more costs in terms of the infrastructure to set up a public 5G network. So what we're going to foresee is that many countries are only core cities or core areas, they will start to push out public 5G. So private 5G, for people who can't wait, is also gaining greater interest. Okay, especially, and then when we look at 5G and all this, the MEC, multi-access edge computing, also comes into play. And you also start seeing a lot of telco 5G providers seeking collaboration with IoT partners because they need to find good use case, okay, things that can stick. UCPE is also another universal customer premises. When we look at that, it's usually for SD-WAN. So SD-WAN concept, UCPE is typically, I have a software orchestrator, I have VNF, virtualized network function. Each virtualized network function, I will do one for next-gen firewall and one maybe for router, one for other function. So now you start to see a lot of universal CPE provider also coming out of VNF just for IoT gateway. So partnership is there. Telco is also looking to new partners, see how they can monetize revenue per customer. Okay. Another trend when it comes to the software is containerization. Okay, especially when it comes to the current edge computing landscape. Containerization is very popular because it has revolutionized software development. In fact, in a 5 short year, their popularity as a tool has actually skyrocketed. Main reason, I would say, containers create vast economy of scale. They are more portable because the container host environment are very consistent. I don't care which type of OS you're running on. Okay, I can shift from here to another. And containerized applications are easy to scale because containers can be added or subtracted quickly from an environment. You look at different container management tools such as Kubernetes. you can also have functions like load balancing. In fact, Kubernetes is currently the most popular container management tool. And there are two types. The main one, KAS, that's the main one when most people refer to Kubernetes. And then there's also another version called lightweight Kubernetes, K3S. Okay, K3S are actually more targeted for resource constrained deployment. Okay, so we are going to start to see more and more deployments in this aspect. Okay, so this is basically a very good rundown of how edge computing, what you can foresee, and the need to drive edge computing. I'll hand over to Alice. She will be elaborating more on the second session of the talk of the discussion. Thanks, everyone.
Yeah, thank you, Mr. Evintio. Yeah, let's move on to the second speaker, Miss Alice Liu, the product manager in Taiwan, to share on introducing of edge intelligence system. Over to you, Alice.
Hi, PC. This is Alice. Can you hear my voice?
Yes, very clear.
Okay, so good afternoon, everyone. I'm Alice, and I'm PM of EI. Today, I will introduce you our brand new product, EI52, and this is the Edge Intelligence System, which we especially designed for the AIoT applications. Next slide, please. So there are three aspects that make EI52 a perfect choice for customers to build their AIoT applications. First is the system is ready to use with the memory and also storage built in. And the system includes the adapter in the package. So users only need to plug in the power and they can start to experience the high performance of latest Intel 11 generation, which is codenamed Tiger Lake UP3 for their computing. And secondly, EI52 pre-installed the Advantech EdgeX data acquisition software package, and then users can use this EdgeX to accelerate their development in IoT data acquisition and connect their sensor data to cloud. And the other important aspect is that EI52 has the expansion support for both 5G and also AI module, and to fulfill the demands for high speed, low latency communication, or when you need an add-on power efficient visual AI computing. So with all these three aspects, we believe that EI52 can be a perfect solution to their users that may need a edge intelligence system for their AIoT applications. Next slide. Okay, so next, I would like to further introduce the built-in data acquisition software EdgeX, and in order to give you an overall understanding on the structure, and for the details, our software PM Gordon will introduce in the next section. So generally speaking, there are three key pillars in IoT field. There are sensors, gateway, and cloud. So the flow of IoT data will start from being detected by the sensors, pass through gateways, and finally arrive cloud and complete the connection. And EdgeX position is between the sensors and cloud. So it provides a variety of device connector to bridge the sensors data and also supports diverse cloud platforms. Through the tools it provides, EdgeX accelerates the whole process of connecting sensor data to cloud. And more specifically, EdgeX brings value to developers in terms of four categories. There are device connection, data processing, preliminary edge analytics, and across cloud platforms integration. And especially for device connection to the cloud, customers can complete the whole process with low code quickly with our Advantech EdgeX. Next slide, please. So after having an overall understanding on EdgeX software package, let's shift the focus back to EI52 feature highlights. So the system is with Intel latest 11 generation platform, and besides the high performance on CPU mark and graphics, the Intel 11 generation processor's core platform also offers the special VNNI instruction set, which Edwin also introduced in the previous section. This VNNI instruction set is especially designed for the AI inference acceleration. And based on our internal benchmark, with the VNNI instruction set accelerated, the performance can be significantly improved on the inference performance. And Other features including HDMI and also DP dual display, both at 4K resolution, and we have the essential input and outputs in a compact dimensions, which are just only a little bit larger than our palm. And also on the software part, pre-installed EdgeX software package, and also DeviceOn for remote control and management. So next slide, please. Please go to the next slide. Yes. EI52 targets at 3 different applications, and the first one it is suitable for the smart city applications because it had the pre-installed EdgeX software to accelerate the connection between sensor data and cloud, and on the other hand, it supports the 5G optional module. So if the application requires a high speed of communication, then the platform is ready. And the second application market is for the factory automation. And for this kind of applications, EI52 offers the pre-installed voice DeviceOn for users to remote control and also manage the device easily. And besides the remote control part, there are also data security and recovery services bundled with McAfee and Acronis. And for the last part, the self-service kiosk, EI52 has the small, compact dimensions and also have the add-on AI module with the low-power Intel Movidius BPU on board. And on the software part, EI52 supports the face recognition, high-precision application FaceView. So together with the software and also AI module, in the self-service kiosk, EI52 can offer both software and hardware solution. Next slide, please. So in the next session, I will go deeper on the pre-installed software for EI52, and there are 2 main packages. The first one is EdgeX, and the other one is voice DeviceOn. So next slide, please. For the EdgeX, as mentioned in the previous section, it is for connecting edge data to cloud. And in terms of the main features, there are 3 points. The first one is that EdgeX provides a variety of device connectors, and it supports a lot of data protocols. So we will go have the device support list later. And the second one is EdgeX supports multiple mainstream public cloud platforms, including Microsoft Azure, Amazon AWS, and also Ali Cloud. And EdgeX also supports our Advantech WisePass platform, and we have the SDK for second development with standardized data format. And last but not least, our Advantech EdgeX is developed based on the open source platform EdgeX Foundry. So the relationship between Advantech EdgeX and EdgeX Foundry is kind of cooperative. So on the one hand, the users can benefit from the innovation from EdgeX Foundry community, and also can have the user-friendly tools that Advantech provide to accelerate their deployment. So next slide, please. So here's the support list of Advantech EdgeX device services. On the left-hand side is the supported data protocols, and on the right-hand side is the list that the devices that we tested. So as you can see, on the left-hand side, Advantech EdgeX supports the common protocols such as MQTT for IoT, and OnVIF for the visual data, and also USB for various devices. And so far, there are already a bunch of devices tested as the right-hand side shown. And for the detail of other features like the user interface, Gordon will elaborate more. Next slide, please. And apart from EdgeX, EI52 also pre-installed voice DeviceOn, and voice DeviceOn has 3 main features, which are device monitor in real time, remote control and manage the device with user-friendly user interface, and also the data security and recovery services. So next slide, please. Here is the UI snapshot for you to have a sense on what kind of items that DeviceOn can control. And for the details, Andrew will elaborate more on the later section. So next slide, please. And here is the data security and also recovery for Acronis and McAfee. Next slide, please. And now we move to the optional part that EI52 can support. First is the 5G communication. And for 5G, EI52 platform is ready for the AIW355 module. And to use with the AIW355, EI52 have to combine with the AMO adapter and also the customized thermal solution AMKA0039. And for the whole package is still under development and will target ready at the end of July or the beginning of August. So next slide. And next one is that EI52 also supports Wi-Fi module EWM-W1A9 H02E. And for this module, we are getting the CE and also FCC certification, and target will be ready in Q3. Next slide, please. And the last optional module is the Vega 330 AI. This one is with the low power Intel Movidius Mirror X, which has 2 VPU on board. And to use with Vega 330, we also have the customized thermal cover for using this module. And the module can provide up to 8 TOPS computing power at only 7.6 watts power consumption. And the whole solution is fully support Intel OpenVINO software toolkit. And next slide. And besides the hardware module, we also have the FaceView industrial app software that offers high precision face recognition and also mask detection to detect whether the mask is put on or detect the identity even when people are wearing a mask, and also the body temperature. And this industrial app comes with friendly user interface for users to check the detected results in real time. And also there is SDK for users to integrate with their existing systems and create a complete application like access control. Next slide. So here I will give a highlight that what exactly can EI52 plus FaceView bring values to building an access control system. So next slide. So the first ones during this COVID-19 situation, it is better to avoid the unnecessary contact. So using FaceView to build an access control system, it would be a touchless solution. Next slide. And the second one is that because this is the access control application, so the precision is important because that is important to control who have the access to enter the restricted area. And on the other hand, users would also not want the false alarm. So for FaceView, the detection kernel can reach the 99.7% accuracy rate. So that would be a good precision rate for access control system. Next slide. Yeah. And for integration part, FaceView also offer the application-driven SDK and also API because some software solution may have a complex SDK, but it is not application-driven. So when developers want to develop like access control system, then they have to find the related section in maybe a whole 1,000-page SDK document. But for FaceView, the document is application driven, especially for the access control. So that will save a lot of effort. And next slide. And the last part would be the additional hardware computing power at low power consumption that Vega 330 can provide. quickly a recap on EI52. EI52 is the compact edge intelligence system with the latest Intel 11 generation Tiger Lake UP3 processors, and also with a software plus hardware EdgeX, DeviceOn, optional 5G, Wi-Fi, and also AI module. And this system is especially designed for the IoT applications. Next slide. Let's see several application scenarios. The first one is the FaceView Touchless AI control system. So in this scenario, our users deploys EI52 at the entrance and integrates with FaceView with their backend with the SDK. So when people's face is captured by the IP camera, the streaming data is transmitted to EI52 for AI detection, and then the detected result is sent to the backend to decide whether to grant the access. Next slide. And the next one is an application in retail. So in this case, EI52 is equipped with Wi-Fi module and deployed inside the retail robot. And when the retail robot moves along the aisle, then the scanner will scan through the shelves and detects the abnormal situations, such as there is out of stock, wrong price tag, or wrong product. And the detected results are transmitted by Wi-Fi to the backend server, and the backend system can notify the staff to fix the issues immediately. So with the whole EI52 with Wi-Fi, EdgeX, and DeviceOn solution, this AI notification system will save retailers' man cost and also enhance the operating efficiency. Next slide. And finally is the application for factory automation. And in this scenario, EI52 with EdgeX is deployed in the factory and connect to WISE 4012 I/O module and also the PLC to realize the automatic control of water pump. And this one is according to the liquid level and temperature. So the whole solution will reduce the man cost for monitor the liquid and also thermal status, and can enhance the operating efficiency to adjust the water pump more in time. Next slide, please. So that's all for the introduction on EI52, both on its structure and also the feature highlights. And next, I will hand over to our software PM Gordon to introduce EdgeX.
Thank you so much, Alice. Okay, our third speaker, I would like to call upon Mr. Gordon Chen, the software engineer in Taiwan. He will be introducing the Edge Intelligence System, EdgeX series. Over to you, Gordon.
Yeah, can you hear me?
Yes, can.
Okay. Hello, everyone. Good afternoon. This is Gordon. I am software manager in Advantech, Taiwan. Next, I will introduce EdgeX, how to accelerate the data collection and push them to the cloud. In this section, I will introduce Open IoT Edge middleware EdgeX basic concept and how it works. We expect there are three key takeaways for this introduction. First is EdgeX data flow from southbound to the northbound. Secondly, is EdgeX device service, how to use it. Third, by walking through EdgeX UI console, you can experience EdgeX key features. In today, system integrator or application developer are facing some requirement or problems like heterogeneous equipment integration, cross-platform support requirement, distributed processing, enterprise application integration. They are also facing some new requirement or challenge for IoT and AI application development, like cloud or SaaS application integration, edge AI application integration, cost of efficient data convergency, business success for time to market and time to profit. So it needs a unified edge IoT application framework to fulfill this kind of requirement, including the southbound heterogeneous sensors and the diverse northbound applications. That's why EdgeX.
Oh, okay, okay.
I will elaborate this in next few slides. EdgeX Foundry is a collection of open source microservices. These microservices are organized into 4 service layers. The service layer transverse from the edge of a physical layer, that is device service layer, to the edge of the information layer, that is application service layer. And the core and supporting service layer are at the middle. There are 2 types of SDK to assist in creating northbound and southbound side services. They are device service SDK and the application service SDK. These microservices are leveraged and deployed with Docker container technology. REST communication for all API calls are supported amongst these microservices. Next. In this page, I will explain EdgeX data flow from the southbound to the northbound. Step 1, sensor data is collected by the device service from a thing or sensor. The step 2, the data is passed to the core services for local persistence, and also provide unified API for the application to access the sensor data. The step 3, the data is then passed to the application service for transformation, formatting, filtering, and it can then be sent to the node to the application, enterprise, or cloud systems. Finally, the data is then available for edge analysis and can trigger device edge agent through command service. This is all kind of this microservice, how it works. Next. Next, I will show you how to set up the device service and how to collect sensor data. I will use a simulated Modbus device for the demonstration. The demo environment will use EI52, Win10, and the EdgeX SDK. Before beginning, in Windows, Docker containers are completely isolated from local machine. So, in order to share Windows folders with Docker container image, you first need to configure the share drives option in the Docker desktop settings. In this page, I will describe how to prepare the device service. Each EdgeX device service consists of 3 parts: the device service, device profile, and the device configuration file. EdgeX uses a device profile to describe the device, its data format, and the supported commands. In this example, we use the open source Modbus device service from the open source community, so you can download from the below link. And we set up the Modbus device profile and the configuration sample in the Advantech GitHub. After you download both of this, then deploy the device, the Modbus device service with the Docker command. Then the device service is running. Next. In this example, we use a simulated Modbus application to simulate the Modbus device. It's called ModThings32 application. You can download it from the link. After you download this, then you download the sample configuration from our Advantech GitHub, and then load the sample configuration into the ModThings32 application simulated Modbus device service. You can check the configuration in the tool on the left side. Now the simulated Modbus device is connected to the EdgeX Modbus device service. The data is collecting to the edges. Next one. So next, I will use EdgeX UI console to demo the device service. The EdgeX UI console is for demonstration and the developer use. Especially, it can manage the EdgeX objects like device service, device profile. Also, it can monitor the EdgeX data flow like event and the reading and the services. It also can monitor and manage from unbox with the EdgeX on the same host. Just reminding, the EdgeX UI console is not meant for production use. It is only for development and the testing purpose. Next one. So first, open a browser like a Firefox or Chrome. Then input the IP and the port to launch the EdgeX UI console. Then log in with the ID with the name and the password. Next one. EdgeX UI console. It allows multiple gateway usage. So first you need to specify a local EdgeX gateway which you want to monitor. So you input the local gateway IP and the port. The IP after the gateway configuration, now you can select it and monitor the gateway objects. Next one. As I mentioned, you manually create the device profile and download from As I mentioned, you manually create the device profile and download it from Advantech GitHub. In this example, Modbus configuration is downloaded from the link. Then use UI console to import or check the device profile. You can see there are two sensor endpoints are defined on the left hand. The first one is the value. It supports the read command. It can get the temperature and the humidity. The other one is the configuration endpoint. It supports get and set command. It allows you to set or get the fan status and the light status. Next one. EdgeX uses a device profile to describe the device and its data format that I mentioned. In the Modbus example, both device and the device profile are created manually and downloaded from the link. If the device configuration was not created in advance, then you can use EdgeX UI console to create it, like the left side. In this example, Modbus device service, we set the Modbus protocol TCP/IP, TCP, and the address and the port and the unit ID. Next one. After this, then you can use EdgeX UI console to get and set Modbus device. At the left side, you select the get method for the value endpoint and press the command button. It will send the command to get the value from the Modbus device. The result, the return is a JSON format. It includes two types of values, the temperature and the humidity. The result match our configuration. The default value for temperature is 50, and for humidity is 70. Okay, next one. Then you can also set the configuration endpoint to Modbus device service with the EdgeX UI console. For example, you can set the fan to 0, light to 0, then press the send command button. Then you can verify the result on the right side hand in the MobSim32 application, the simulated Modbus device. Okay, next one. Okay, as we mentioned before, all microservices, including the device service, support the REST communication or REST API. User application can program with the REST API call to get or set the device as the following. The command is like a URL. It composed of the HTTP, IP port, and the path, and also the device name, command name. In this example, the port represents the device service port. For example, 49991. The device name represents the physical device or resources. For example, WISE 4012. The command represents physical sensor node or single I/O port. For example, the value or the configuration. Next one. Okay, let's the device profile. Let's the device service. So after this, all the device you can control and collect the Modbus device data with the EdgeX API. After you collect data, the data is collected into the EdgeX message bus. Then you can use our cloud connector like Azure, AWS, or RD Connect to push the sensor data to the cloud. You can follow the SOP on our EdgeX technical portal to push the data to the Azure. You can also refer our example on the GitHub to access or parsing the data on the cloud. As our experience, if you want to do it by yourself to send the data to the cloud, it may take 8 to 10 weeks at least. With EdgeX built-in the script, you only need to take about 30 seconds to configure several parameters. Then the data can push to the cloud without any code. Next one. So this slide, our PM Alice already mentioned that, so I will skip this one. So this is all for today's introduction. If you want more information, you can check EdgeX technical portal shown in this page. Thank you for your time. Thank you, everyone.
Thank you, Gordon. Our last speaker, Mr. Andrew, the key account sales manager in Indonesia. He will be sharing on the DeviceOn remote management utility. Over to you, Andrew.
Okay, PC. Thank you so much, everyone, for your coming. My name is Andrew from key account for embedded sector in Indonesia as well. I want to share regarding what the application of software, our strong security remote management. Okay. When we are coming to the IoT solution, the difference is we will have a multiple massive of number of devices, and it will be deployed in multiple sites, such as in medical, retail, or in manufacture as transportation, but it will be connected each other. So it's very critical and very important for us to be able remotely and manage our device and then get the real-time data. But to be frank, it's very challenging to be execute and done. Okay, next slide, please. For this, Advantech introduce our strong application, what we call Wi-Fi DeviceOn. Wi-Fi DeviceOn is asset management software that will allow we to remote monitor and manage our device, even it's across multiple sites. And then this solution fully equipped with Advantech core software Wi-Fi DeviceOn to provide equipment management such as and then data management, application software management, and multiple cloud platform integration service as well. Next slide, please. And then with device on core function, we can do it as I mentioned before to manage the equipment, data management. Besides that, we can also accelerate the implementation of the edge computing that intelligent application itself. It will be elaborate on the core software of Wi-Fi DeviceOn in this. Then Wi-Fi DeviceOn also can be quickly deployed on various edge computing platform. So it's just provide the plug and play equipment management and also data management services. Also, Wi-Fi DeviceOn is to provide flexibility of business integration, including application software management and integration service for various cloud platform. So I want to share a little bit a short video regarding the Wi-Fi DeviceOn, how we can monitoring the status from anytime and from anywhere. This is the overview for our friendly dashboard. It can be monitor every single thing in our devices, and then we can manage our devices remotely as long we have the internet connection. Also, we can do take real-time action, troubleshooting, and then from here we can monitoring the inside the device in mapping area in different site. I put example, this is for 3 devices in different area. You can see the green one is the online, and then the gray one is the offline. And then we click in on detail from each devices. We can see how many CPU usage, the memory utility, and then the throughput of the networking, the traffic, and then also the temperature inside of our devices as well. So the next ones we can do also, as my colleague mentioned, we can remotely also to each device, like the screenshot and everything. So we also can do a bundle with backup recovery and then protection with McAfee. Also, last but not least, we can also notify if some troubleshoot or some problems are faulty through the email or social media. And the powerful one is we can do the patch over the air remotely. You can do everywhere as long you have the internet connection to do the software patch or firmware patch for each device massively. Okay, next one, please. Next slide. Okay, I want to share a little bit regarding the package inside of our Wi-Fi DeviceOn for McAfee embedded security and electronics backup recovery solution. So McAfee is the application they proactive to give the protection to our system, which a maximum operational impact, and then we can control the device to the life cycle. Also, no matter what the type of device you need to secure, McAfee will bring to the right technology to help you. Next slide, please. Okay, during this presentation, I will share an overview of the three product sets that describing the environment and then the market benefit most from the each product. Some quick snapshot I will share. This one is when we use the blacklisting is the left side when the antivirus solution that suitable to file based and scanning and protection against some known attack typically since in the PC or removable media market. And the green listing is reputation-based model to manage service provider, web server, firewall, or gateway is anywhere that is dealing with web traffic or with content such as a URL and etc. So what we offering on the right side is whitelisting. This is a relative new approach to secure where the understanding what only the application trust uh, can execute on the system. This approach is very well suited for fix the function of the devices. Next slide, please. This is what comparison between the traditional antivirus and what we call blacklisting, and then what we offering with the new one, we calling whitelisting. The per day antivirus will be definitely update on the traditional antivirus. The efficiency on the whitelisting uh, is very low on CPU resource because it's not scheduling up scanning and scanning. It's only running when some execute file coming, and then it will be checked on the list. If not not authorized on the list, so it will be not execute. So it's more lower on CPU on system resource. And then it's protect again the zero-day attacks. I want to elaborate more a little bit what we call a zero-day attack protection. Let's say the hacker discovers some vulnerability in our operating system. Then he can create a new virus to attack through this vulnerability. And then he will launch the attack by infection some computer. So it will be definitely some complaint from the user to, let's say, to Microsoft lah. And then Microsoft will be notified and ask to the technical expert, hey, please dig out about this new virus and find out the vulnerability and solve it, do it some patch to close the antivirus. Then after this, notify all the antivirus company to add their virus definition file. When the end user IP admin download the latest virus definition file, then the system is starting to protect it. So this entire virus from the date when the hacker found the vulnerability and then the IT team installed the virus definition, this is what we call the zero day protection. And then what I want to highlight on this on the blacklisting also is the typical antivirus software. This blacklisting it shall always scan on the background. So it means in reality, in fact, it does not scan everything inside the system. The antivirus software only scan for common virus, not all, because to scan all, you will need to stop everything and do full system, and then this is take CPU resource and very high CPU resource on the computer. Then the computer shall shut down and scanning for all. But for whitelisting, don't scare anything, everything. But it only check when you run any executable file and will be verified whether the file had been whitelist on the in the beginning or not. Okay, so make a full circuit product. We can do some application control, the three main, and then change the control. Also, some a policy orchestra is to centralize the management. So application control is to proactive the protections, reducing the maintenance work, and then to prevent the unauthorized application installation when we're doing the listing in the first time. And then, as I mentioned, to protect again the zero-day attack automatically. For the change control, this is to give a right who and when and what to access the system. Then prevent out of the policy changing, because it only several people who will authorize to do this changing for the whitelisting executable. So, and then e-policy orchestration is to manage the McAfee configuration, and then the policy from a single location, also to generate performance and compliant report automatically centralized. Okay, next one, the third-party application that's supporting on our WisePass DeviceOn is the Acronis backup and recovery solution. This is the third-party application where they engage together with our WisePass DeviceOn to make a full, complete, and powerful application. Okay, Acronis, some main feature I want to share is the benefit of Acronis backup and recovery is rich backup and recovery tool, and excellent backup capabilities and easy data restorations. There's more information on its benefit. You can see in here like complete business protection with Acronis backup is considered to be one of the top solution. It comes to the field at data and backup recovery. The reason for that is that the system is loaded with backup capability and extensive feature. They are backed by customer support. And then not only that, but Acronis backup and recovery also come with serious, highly advanced tool that can easily fill small business on big business and such of backup and recovery needs. I want to highlight on easy and recovery and restoration the data. User will find that both small individual file on a huge amount of data are easy to recover and restore with this Acronis backup tool. And then the tool is provide user the option to restore and then definition on different location in case they don't want to do a recovery in just one machine. The option to recover data to new location, new hardware, completely different than the previous used one, is also available. Next one, please. So for controlling this McAfee and Acronis in the WisePass DeviceOn, Advantech provide this what we call Advantech utility. It can control the McAfee and Acronis just only configure and update by using McAfee management, so user friendly dashboard. So no need to use the command line to type on to change the policy and update the whitelist and authorization, such etc. Next slide, please. So this is our partnership with these two third-party application. So this is the advantage what we're doing starting from 2011. This with Acronis, also with McAfee as a global distributor. Okay, next slide, please. So I want to share just a few of our successfully regarding this implementation of WisePass DeviceOn in the manufacture. This is on the smart conductor and smart production using DeviceOn to increase the production and utilization. And then next one. This is on the flight information display system to update the content, to update the to monitor the screen, and then Windows pop-up then automatic some alert notification, and then also we implement the McAfee on whitelist protection inside. So at the last one, at not least, this co-creation is very important because for sure is nobody can do the IoT alone. So in this IoT era, where you no longer can only work with only hardware only or software only. For sure, you will need to bond these two software and hardware together to be able to reach a successfully journey. So my last slide is please feel free. You can visit us on the advantech.com or you can drop the email after this. If you want to trial some demo on Wi-Fi DeviceOn, we can provide it for you, or you can contact the closest RBU of Advantech as well. Thank you very much and keep safe and healthy. Good afternoon, everyone.
Thank you, Andrew. Yeah, now come to the session, Q&A session. You may unmute yourself if you have any question, or alternative, you may post your question in the chat box.